Is this you? Have you ever been cleaning the gutters and been worried about your safety and effectiveness of the tool? What if the Gutter Geeks have the product for you? Gutters protect against structural damage by diverting rainwater from a home. However, an unavoidable consequence of gutter use is that they collect various types of debris in addition to water. If the gutter is not periodically cleaned, the debris will build up and eventually spill over the side of the gutter and cause the gutter to sag and leak water. This excess of water being dumped at the base of your house can cause the said structural damage. Existing methods can be both messy and dangerous while also being inefficient and ineffective at clearing the heavier debris such as wet leaves, sticks, and acorns. A tool that can eliminate these problems and alleviate the mundane nature of the job is desirable. To achieve this, the tool must satisfy the following requirements: clear standard 5-inch gutters from the ground, clears various types of debris, clears beneath gutter hangers and other obstacles, be lightweight and intuitive to use, and safe for the customer.
The function tree helped the team understand all the functions that the tool would need to perform, especially the less obvious functions like how the user would detect the position of the tool, since the user will be operating from the ground and will not be able to see inside the gutter. Once the functions of the tool are established, the team is able to brainstorm and organize ideas into a morphological chart. For our tool, the most critical function, of course, is how it will remove debris. The team established 4 design alternatives, each with a unique way of removing the debris. A shop vac jet was eliminated due to added complexity and messiness from the water. The vacuum mulcher was an interesting idea that would have used a mulcher powered by the vacuum, but ultimately was disqualified as the vacuum would not provide enough suction to make the mulcher effective. This led into the second evaluation matrix, which honed in on the more important customer requirements and the requirements that differentiated the 2 remaining designs. The mulcher would mulch the leaves at the top of the gutter and likely be heavy and more unsafe for the user. The power spin brush, however, would be much lighter at the top and scored higher largely for these reasons. Additionally, in some preliminary proof of concepts, the brush operated on a power tool outperformed the other tools. It was decided early on that the tool would operate off the expanded series so that customers could easily attach it to their tool that they already have. The prototype followed 4 main stages. The initial stage was finding a brush that could effectively remove wet and dry leaves when attached to the expandant. The whole team worked together in this phase to determine the best brush to use is a brush that fills the gutter and is soft enough to conform to the gutter. Once the brush was found, the team split into subgroups to ideate on how the tool would angle into the gutter, design a guard to protect the user, and establish a guiding mechanism. The initial prototype used a string trimmer attachment, which the brush was retrofitted onto. This was problematic as it was a very awkward angle for the user. The team decided to curve the shaft from vertical to 150 degrees, at which point it would angle 90 degrees into the gutter. The guard was designed in a curved shape to allow the leaves to be guided towards the ground. A dolly wheel mechanism was tested and determined to not be a good fit. The dolly wheels were far too bulky and would prevent the leaves from reaching the brush. To test the tool, the team created a mock gutter. This gutter was filled with leaves and would be propped up on a table. The tool would then be used to clear the gutter. Once the gutter was cleared, with one pass of the tool, the downspout was clogged and the gutter would be filled with water. The clog would be removed and the time to drain, a certain amount of water would be recorded, yielding a flow rate. The goal for this flow rate is to be greater than 400 cubic centimeters per second, as this would accommodate a heavy amount of rain, allowing the water to leave the gutter as quickly as the rain fills it. A fully clogged gutter was tested and it drained at 90 cubic centimeters per second, as opposed to a completely clear gutter, which drained at 580 cubic centimeters per second. Clearing dry leaves, our tool was able to clear the mock gutter to drain at 560 cubic centimeters per second. Clearing wet leaves, we were able to get as high as 300 cubic centimeters per second. We believe that with further testing and experimentation, our product can clear wet leaves, allowing for a flow rate greater than 400 cubic centimeters per second. As for the gutter hangers and end caps, the tool can interface well and clear them out. Despite not being able to see inside the gutter, the user is able to feel the resistance when a gutter hanger is reached and move the tool around the hanger.